Good afternoon, everybody. My name is Paul Williams. I do so much appreciate you leaving lunch behind, or actually probably bringing it with you, I guess. And if anybody falls asleep during this, I completely understand because the food was so good, right? But hopefully I can keep you entertained and amused for the next hour or so. But yeah, I really appreciate you all being here. So I'm going to talk about becoming an engineering manager without losing your technical soul. And this is the first time I've talked about these thoughts in public. So I really appreciate you telling me what you think afterwards. It'd be really interesting to hear your perspectives as well. This is my team I work with, amazing bunch of people in London. And we are called, well, actually, I'll tell you who we're called. I'm an engineering manager called Paul Williams. I work for a company called Bloomberg. I'm part of the application infrastructure and experience team at Bloomberg. There we are on X. And I'm going to be talking about the journey into leadership for someone who really, really loves to code. And I really do love to code. So this is kind of my history. Some of you who were here 2 years ago may have seen some of this. I started programming when I was 15, and the school I was at had one computer, one of these Commodore PETs. This incredible little keyboard here. I soon discovered that actually publishing Commodore BASIC programs in a magazine was more lucrative than delivering newspapers once a week. So that was my changing career at the age of 15. And this was actually my first game that I published. I found it, somebody got it running in an emulator quite recently, which is quite funny to find online. I kind of progressed into the era when one person could write arcade games. It's kind of interesting how things have changed recently, and we'll come back to that. I really sort of cut my low-level programming teeth with music, actually. So this here is actually, I was at uni, apologies for the 80s clothing. This was a Commodore 64 with a homemade MIDI interface wired up to some keyboards. I was at a student union concert playing, and this is actually a hacked drum machine where I was actually literally printing rhythms to the drum machine from the printer port. So 8 pins on the printer port could actually trigger 8 drum sounds on the drum machine. So it was fun times, actually. I kind of then got a little bit more serious in coding and ended up programming kind of high-performance computing, custom hardware parallel systems for 10 years, mainly for machine vision for robotics. And we were kind of trying to do AI, but AI I guess this was the early 90s, meant lots and lots of if statements, basically. And expert systems, I think it was called at the time. Everybody talks about the failed generation of AI, and I think that was it that we were basically in. And then I've spent the rest of my career since mid-90s at Bloomberg, and I'm still there and still loving it. So I'm going to talk about an interesting conundrum. I was in a town called Northampton in the UK for the first time one day. I had to be there, and I knew there was some stuff going on at work, but I had to be in this town. And the first thing I do in a new town when I go there is look up on the web, where's the best coffee? And the response I got was this place here, the Good Loaf Bakery, actually it was called. It was actually a converted shoe factory. I discovered, while I was drinking my coffee, that this town was the epicenter of shoe production in the UK in the past. So this vital infrastructure for the country was made in this place, and this place was now a coffee shop because that industry had obviously subsided. A lot of manual labor had gone, but this place had pivoted into being this amazing bakery and coffee shop where they were actually, it'd become a real community hub. They were taking people out of difficult circumstances and actually putting them into work in the bakery, in the coffee shop. Really, really great spirit there. As I knew I needed to check in with work, and so I opened my laptop, and something really interesting was going on. So we'd been working on this issue with some of our clients, and we were in this very interesting position where, because of the size of our user base, and I'll talk about what we actually do in a moment, our sales team actually know every single client individually. And so if there is any kind of issue that we need to work through them with for our system, then we can actually get very close access to individual clients and work with them to work through any problems. And there was a problem going on, which we were trying. I was just checking in on to trying to understand. When in these certain environments, people using our product couldn't see data updating. So what is our product? This thing called the Bloomberg Terminal. In the past, it used to be custom hardware. Eventually we changed to running on the platform that most of the banks of the world run on, which is Windows. So you can think of it really as a custom, real-time focused browser that displays you everything you might want to know about the finance world, about business world, every bit of data you might need to make the most well-informed investment decisions, for example, or anything to do with economics, anything to do with funding, borrowing, any of these things. Hopefully, you can find the data you want in this system. But something that's very characteristic about this system is that it is real time. So unlike most browser-based web systems, it's very much about push model data that is pushed to the desktop, whether it's prices updating, possibly market affecting news headlines coming through, economic releases, TV, obviously, all kinds of real time data, has to be displayed accurately and on time, wherever you're using this in the world. Now, this is installed, you see it on the TV. Usually when the markets are crashing or something, you'll see pictures of a trading floor, all the numbers showing red on the news. That's often, our system that is running. Our system's not making it go red, but let me be clear there. So when this isn't updating, that's a problem, right? Because obviously you need good access, timely access to live data if you're making these kind of business decisions. So this problem, it was so interesting. We'd been working on it for a few days, actually, trying to understand what was going on. There were just certain, test environments that clients had where they weren't seeing live data. We actually got all our engineering hubs involved around the world trying to understand this problem, because as much as we looked at our code, we could not find anything wrong with it. Certainly in this particular code path involving updating data. And why this was so memorable, this particular puzzle, was that I saw people from so many levels in the organization involved in trying to figure out what was actually going on here. We were looking at logs. I actually remember we sent in one of my colleagues to actually go and sit with one of the tech teams at one of the banks to actually capture dumps of processes and to try and understand why is real-time data not updating. Just odd, this system. So taking a step back, this is kind of very, very basically how our system works. So this is the kind of the webby part of it, where basically we're going to have the equivalent of web servers running on the back end, talking to other services that are going to be sending some kind of UI definition and data processing rules down to the terminal, the browser running at the desktop. And that will give you, non-interactive or, non-real-time screens that look like this. You can, every time you want to do something within this application, within the terminal, you're going to be talking back to our servers, most likely. But of course, that's not enough. We need streaming data as well. So to get streaming data, we have something called the ticker plant, which is our term for our real-time database. pretty big deal, chunky database that is literally supporting billions of updates per day, and is storing long-term, very high precision, high fidelity history for all these different types of instruments that are changing in the financial world. So that stream of data is delivered to the terminal. Now that's compared to the interactive stream, that's quite a high frequency stream of data. So in order to support that working well across the world, we have a network of a sort of tree of fan-out systems that deliver that data to the terminal. Now, why am I telling you all of this? So the UI path here is basically the only thing it's delivering to is something running on Windows. So understandably, the networking stack for that blue path is written using Windows. The WinSock library on Windows for those that are Windows programmers. It's just using because we didn't need anything else. It only runs on Windows because that is what the entire financial industry uses on these trading floors. However, the real-time data path uses all these nodes on the way. In our different, we call them node sites. We have some in Asia, for example, east-west coast of the US, in Europe, and so on. These are actually Linux machines. So the code running on these is much more Linux style. We also, the kind of endpoint of that code is also reusing the same code. So actually that path is cross-platform code running using the POSIX layer that is supported under Windows. Again, why am I telling you all these details? So we were looking inside what's going on in this real-time data path that in some cases seems not to be working. It just so happens that in that code, we have a way of signaling between threads. So we may have one thread that is waiting on the network. It can also be waiting on some internal signal from within the same process from another thread to say, I'm ready for you to finish your connection or to validate the connection or run some piece of logic that then allows data to flow. And what we happen to do is we happen to use a local TCP/IP channel within the same process, actually, that is just sending, every time it needs to signal, it sends an arbitrary character. We happen to use the letter S. Why not? For signaling one thread to say, OK, you're ready, off you go. You can serve real-time data into the UI. Little diversion. This is the RFC for the secure cell SSH transport layer protocol. This is not what we're using for this signaling. This is something completely different. This is, as I'm sure most of you know, this is the protocol that is used for secure login sessions across an insecure network. There's a link down here. You can read all about this. But I'm going to save you having to read it by summarizing what happens when you actually use SSH on the wire. The client, the terminal in our case, would, if it was using SSH, would be sending a character stream. This is, you don't have to do anything. This is the test alert for Ontario. Nothing to do with SSH. There's been no security breach. Everything is good. How long does it last? Is that it? Or do they do it again? They may do a second one. Okay, nobody be alarmed. It's all good. Okay, if it goes again, we'll have another giggle. Okay, so client sends a stream like this to say, I'm trying to talk SSH, and I'm this version of the software, and I'd like to talk to you. The server says, hi, I'm also SSH. I'd like to talk to you. My version is this. And then after that, there'll be some kind of exchange of keys and all the kinds of things that allow you to have a proper secure communication going on. Do you notice something about this protocol? It likes the letter S. Just imagine you were writing a piece of anti-malware to run on a system. What might you do? You might say, well, I'm going to do some clever system hooky stuff. I'm going to intercept the TCP/IP stack, and I'm going to look for malicious data that's being transmitted between different parts of either within the machine or going out of the machine. And if I find something that's really bad, I'm going to run all my heuristics and I'm going to block that connection or flag it up or something. Fair enough. If you were writing a bad implementation of an anti-malware detector, what you might do is you say, well, whenever I see an S, I'm going to hold it. I'm not going to let it through because there might be another one coming. And there might be an H coming after that. And tough. If you send me an S, I'm not letting it out. And turned out, we sort of, this is why this was so interesting, because we did not expect to find this. We talked to the tech teams at the clients who were working with us to try and solve this problem. Sure enough, they were all running a particular piece of anti-malware on their desktop PCs. And sure enough, they'd all just updated it. And we had a look. We worked with this particular anti-malware firm, and we discovered this is exactly what they were doing. They'd introduced a feature to try and detect malicious SSH traffic on TCP/IP traffic, even if it was just internal. Now, if we'd actually used what are called Unix domain sockets, which are kind of purely for local traffic within a box, then we probably wouldn't have run into this. The thing is, Microsoft only got Unix domain sockets working in the POSIX layer in a particular kind of half version of Windows 10. Didn't ever used to work. So we had no choice. If we were going to write cross-platform code, it had to be a full TCP/IP connection for this kind of traffic. So what was actually happening is that we were this thing was holding on, and eventually it would see the third S that would come. Think, oh, it's not SSH. Phew, it's fine. And would let this traffic through. But by then, we timed out on the network layer, and this is why nothing could get through. So it was just this really interesting problem that we did not expect. There was no bug in our code. Whether there was a bug in the anti-malware code is kind of questionable. It was a strange way of doing things. It was certainly disruptive, but it was just really interesting. And because of this, I always associate security issues with the smell of bread, because I just remember saying it was such good bread. I know I keep going on about it. Sorry, but it was it was really great, and we've had so many people involved in this scenario. And what was absolutely striking that I found is that in a big organization, we have at Bloomberg across our different engineering centers, we have about 9,000 developers. And obviously there's going to be some structure within there. There's going to be individual contributors, there's going to be team leaders, there's going to be managers, there's going to be heads of department, there's going to be head of engineering. I saw people, who would, in their day-to-day job, would be responsible for 500 engineers, group manager, in the debugger, trying to understand what was going on here, And it really struck me that when we really need to pull together to figure out a problem, people's technical skills that maybe they don't get to use every day really, really can come back. And it really showed me how technically deep our organization was, to actually see people very engaged at a very high level, helping us to solve this issue. So yeah, we talked to the vendor, they fixed their software. We changed our software a little bit, even though it was actually, wasn't actually doing anything technically wrong, but we learned a lesson about, we can not do things like this to make life easier for ourselves, and all is good. But it just really reminded me that you really can have technical depth at many levels in an organization. So I've got 6 questions, and those questions. Well, my stopwatch has gone away because of the emergency alert. I got it too. Wow, I feel like a Canadian already. So 6 questions I'd like to pose. First question is, does an engineer who becomes a manager lose their value and identity? So what do I mean by that? Well, if you think about, for those of you who in here is a developer, not rather than a leader, somebody who just works in a team as an engineer. Some of you, like I was. Seems to me that when you're in that position, some things are really important to you. The code you write, really important, right? There's I think a lot of your identity actually gets tied up in the actual code that you write. It's something you can be really proud of. something that you hone over the years, your ability, your skill to actually write code that is, does the job, is maintainable, is something that somebody else can read, and expresses itself well, so you don't have to actually write a comment on every line to tell you what it does. I remember in the early days I was writing device drivers for something called the Digital Equipment VAX, as a mini computer, and the assembly instructions were so indecipherable. Every single line had to have a comment on it, or else you just stood no chance of understanding what this code did. The products you build, you should be proud. You make a product that people want to use or do use, and you should be very proud of that as an individual contributor. The skills you have, the things that you learn, they're very precious to you. They are your value when you're trying to get a new job, for example. They're your value when you're trying to get a promotion. These things are really important. And another one, which I think is a little bit more subtle, is every individual contributor has a different view of this sort of set of code that they interact with. They're going to be experts in fields that, bits of code that they touch every day. They're going to have an understanding of the SDKs and the other subsystems that they have to use in order for their code to work. But their actual view is going to be actually unique, compared to the person sitting a few desks away who's maybe got a slightly different focus. So they have a unique skill set. And I think that is very precious. I remember that being very precious to me as an individual contributor. And I think the fear is that you might lose that when you become an engineering manager or a leader of any kind. So I'm going to ask another question, hopefully to try and answer that first question. Question 2 is, what value does an engineering manager really bring? And I think there is a sort of standard textbook answer, which is these kinds of things. Project management, which involves prioritization, reporting, gaining consensus, all these things. People management, something that's very new, something that people can feel a bit scared of when they are asked to be a leader. Mentoring. Now, mentoring, I think, is amazing. To actually feel that you are somehow involved in the growth of somebody else, I absolutely love. It's something that, ever since I had the opportunity to start doing that, I've really cherished, actually. Just be able to provide a little bit of input, just maybe to help steer somebody on a good path, and just watch them grow and develop and become a more mature developer, or themselves move into leadership at the right opportunity. I find so fulfilling. I really, really do. So I think that's a really great part of being an engineering manager. Recruiting, obviously, you need to actually, when you get the opportunity to build the team. But there's a lot more than that. Scaling. I'm going to talk about these things individually because I think they are really important and they tie into this technical theme. Empowering your team, solving problems together, designing systems, advocating for the team. I'll come back to that in a minute, and setting vision for the team. Scaling. I remember this very, very clearly. My boss, when I was an individual contributor, saying to me, "You can't do any more." And I remember, I was burning the candle at both ends, trying to do what I could as an individual contributor, thinking I've just got to, I can get more done today. I don't need to sleep. I remember whether I was in an airport or waiting for a train or in a park somewhere. I had my laptop out, really clunky, heavy laptop in the 90s. The battery would last half an hour, and I was thinking I just have to do more. I'm sure a lot of us get like this at some stage in our lives. And my boss said, "You can't." He says the only way we can scale your output is to have other people help you. And the way we can do that is we can form a team. And because you're the one we want to scale, you should be the team leader of that team. We'll give you the skills you need to. We'll teach you the skills, help you along your way. But this is really important to do this. Empowering. As soon as you have a team, you come to a quick realization that maybe you're not the best programmer in this group. Actually, other people can do things better than maybe you could have done. And I think something that's really important is being in a mindset where you can actually empower the team to do things better than you would have done. We're going to talk about letting go of the critical path in a moment. But what's really important here is giving people a chance, trusting them, to actually do the work, giving them an opportunity for themselves to grow, to do have the kind of experience you had as an individual contributor, to really become a stronger, better, more capable programmer. And you're there to provide technical oversight. The more you can retain your technical knowledge, the more you can help the rest of the team to really do well. I love this quote. It was actually Larry Page, one of the founders of Google, talking to Matt Britton, who for a long time has been the European head of Google. Put the best people on the most important work and get out of the way. I think that's actually really great advice to any leader. There's a podcast where he talks about this, actually. I'm sure we'll be publishing the slides. You don't have to write this down. But it's a really, really interesting podcast about technical leadership. Solving problems together. Once you have a team, you have a diverse set of perspectives. And that's a wonderful thing. That might mean you end up solving a problem in a way that you didn't think of, because other people can bring their own experiences, and you can come together and solve the problem in potentially a much better way. I remember I started a team in Hong Kong 6 years ago or so to focus on telemetry in our systems, and we went out there to recruit. And I remember we saw this really interesting resume from somebody who she'd studied fine art, and her only programming experience was to basically do online hackathons and coding competitions. And she'd done so well at those, she'd managed to get herself a job as an Android developer, developing apps, and done really well for herself. She was still quite inexperienced, but she was obviously a great self-starter. So we thought we should definitely get her in to have a chat. And I remember interviewing her, and I couldn't ask her about a lot of the standard technical questions that I would ask somebody, because it was just stuff she hadn't covered. But when I asked her, how would I break down this kind of problem? How would I go about understanding how to solve this kind of issue? She was brilliant, and by the end of the interview, she was like implementing hash tables from scratch and all sorts of stuff. It was fantastic, so we gave her a chance. We recruited her. She actually lives in Toronto now, actually. And I remember, I was setting her a task one time I was out in Hong Kong and said, we need this UI enhancement to our telemetry system. I think it's going to take a week or two to do the work. Why don't you have a think about how we might implement this. I gave her some hints. I said, because it's a real-time display, here's some ideas from my game programming background of how you might go about doing collision detection of the mouse against objects and all these kinds of things. And I said, I'll just check in with you tomorrow to make sure you kind of understand the brief, once you've had to think about about this. So I talked to her the next day, and she said, I've done it. You've understood the brief? No, I've done it. I finished the task. And I said, can you explain? She said, yeah, well, thanks for telling me your how you might go about this, but actually, I thought of a different way. And because of the nature of how we're updating the screen, every time we update the screen, we can check where the mouse is. And there's actually a much simpler way of deciding whether the mouse is touching anything on the screen. And it was literally, she saved 2 weeks' work. That was a business win because she'd taken a different approach, and approach that I wouldn't have thought of with my ingrained background as a games real-time developer. And that really, really taught me that it's important to have diverse opinions and experiences in the room, because if you don't, you might miss something that's really important. Designing systems. A team can design a system much better than an individual. Again, bring diverse viewpoints and experiences and understanding, and you'll end up, with a better system. Advocating. So something that I found is really important is to big up your team. Have confidence in them. In a way, be a salesperson so that you can actually go out to other parts of the organization and say, my team could do this. My team can help with this issue. And this is why. And it's because of their technical depth and their ability to deliver. Equally, when maybe things come the other way, decrees come down from upper management, and they might be something that you're a little bit uncomfortable with. Maybe it's a change in policy or direction or something. It's up to you to reframe that request in a way that makes sense to your team, and the team can understand the reasons for and be comfortable with. And again, I think that a combination of really knowing the team and also understanding these technical aspects of how the team is working and what the team are doing and what the team are capable of really help in those kind of situations. Setting vision. I think it's really important that the leader in the team does set the vision, and because you're going to find as you're building products, you're going to go off on different paths, different diversions all over the place. But if you've got some kind of North Star of where you're going to come back to, then I think that can really help inform some of those decisions along the way. Where I've noticed this to be extremely powerful is seeing the senior organization structure at Bloomberg. So our head of product on the product side of the business used to be my boss in the infrastructure area. So he's moved over to the product side. But it means that when he's talking to engineers, he can still talk with his technical hat on as well as his strategic product hat on, because he understands the technical side. Our CEO now is also came out of being an engineering leader in our application infrastructure area. So again, he is able to really understand what's actually technically possible. And we all see how the world is changing now. The technical landscape is changing with LLMs and AI and machine learning. Because he has such a deep technical understanding, he knows, nobody's going to pull the wool over his eyes about what AI is capable of practically in a system where the accuracy of data is highly important, the most important thing. So he gets it, and I find that it really helps us in the depth of the organization to really understand what's possible, what's happening, and to know that have that confidence that the leaders in the company have such a strong understanding of what we are capable of and where we could go technically. So put all this together, and I really think the kind of textbook things that an engineering leader has to do, plus these other more technical things, I think they're all equally important and actually come together into true leadership. And I think that is so important. There's another quote from that podcast that I mentioned earlier, actually, which I've been dwelling on because I think it's a really deep thing to say. That as a leader, you transmit. You can cast an enormous shadow if you're very negative about anything, or you can shine a beautiful spotlight if you can be positive. And I think having technical depth allows you to be positive because it allows you to navigate and find a way forward for your team. So, question 3. Does an engineering manager have to become less technical because of all these other pressures on their time? So if you think a little bit more about, what are the ways in which an engineering manager really needs to stay quite technical? And I think they're these: breaking down problems, reasoning, systems design, balancing trade-offs, and exploring possibilities. We're going to come back to some of those things in a moment. Big question. Should the engineering manager be writing code? Now, of course, in this climate, should anybody be writing code? But we're talking specifically about engineering managers here. Should an engineering manager be writing code? I think the answer is it's not black and white. I know engineering managers, some engineering managers who write no code, and they don't use LLMs to write code either. They literally love being somebody who can provide technical direction and oversight, but they've completely sort of moved on from that coding passion. And I know other managers, and I would include myself in this, as somebody, I can't let go of coding. I love it too much, But the thing I've really learned is, as I mentioned earlier, if you're an engineering manager, you cannot be writing code on the critical path. That is, I think, the number one thing. Because if you do, the team will start finding ways to work around you to avoid the bottleneck that you are. I think that's really, really critical. We'll talk about what that might mean. Instead, you can do the things that unblock the team. So it might mean that you end up doing some of the less glamorous coding work, perhaps. That can be much more fun nowadays with LLMs, obviously. Unblock them. Let them be effective as a team. And by doing some coding, you're staying connected to the code base, but without becoming a dependency. I want to feel the pain of, GitHub's really slow today. Or, we've had to go update the version of the compiler. What does that mean for some of the idiomatic code that we've got already? Something that was maybe actually breaking the spec without anybody noticing in the past. I really want to understand that. I remember there was a point where we were making the transition for some of our application level business logic to move from C++ to JavaScript. The C++ had got so unwieldy that we had to go to the compiler manufacturers and get them to make a new version of the linker that could support bigger than 4 gigabyte executables, something ridiculous, in 32-bit days. And that, we changed, at that point, to compile a link and actually run a change was 20 minutes because the code base was so huge. We changed that to like 1 second by using some scripting languages where was necessary, and also optimizing the tool chain. But it only really happened because people that had the agency to change those things actually experienced the pain, and that was the key. Contribute without overshadowing what the team is doing. Your primary role is to make the team good as a manager, but it doesn't mean you need to actually let go of everything that was previously dear to you. There's a really, really great engineering leadership blog. There's this woman, Kelly Vaughan, who is an engineering manager at Zapier. She has a blog called The Modern Leader, modernleader.is. I highly, highly recommend it. I think Kelly is, out of all the reading I've done about engineering leadership, she is the most well-considered, thoughtful voice on engineering leadership I've ever come across. I commend you to read what she's written. This particular document there is all about this, about engineering managers. Should they write code? She really gets it. There's an all access subscription for like $10 a month, or something, to everything she's ever written. And brilliant work she's done. So what's this meant for me? Question 5. I'm trying to do those things that allow me to do some level of coding, stay connected to what's going on, but not be in the way. And for me, that's really meant 2 things. And they're very related, these things. One is what I call strategic troubleshooting. The other one is observability. So what's strategic troubleshooting? The way I think of it is, when we're trying to understand a problem, we should only suffer the pain of deep troubleshooting a specific issue once. Because in solving that problem, you should build observability, telemetry, better logging, whatever it is that means that that particular problem is obvious next time. And time and time again, I found that to be so helpful, not only for engineers, but also for our support organizations. So something we're trying to do is we have a dashboard which shows us how many customer support tickets come in, get escalated to engineering. And we're trying to improve two things. One is we're trying to reduce the number of customer support issues that come in, but we're also, and I think more importantly, is actually reduce the number of those tickets that get escalated to engineering, because we've empowered our support teams by the tools and the telemetry and the observability that we've included to solve those problems themselves. And that has produced a beautiful relationship between engineering and our support teams, actually. And everybody wins. They feel more empowered to solve problems more quickly. We don't get interrupted so much because that acts as a sort of filter until we get the next complicated problem that we, again, have to then put more observability around, more telemetry, more logging, more way of looking at context and state and so on to understand what's happening. But time and time again, this has really helped us. So that brings me into observability. Now, a couple of these topics I did actually touch on. If you were lucky enough to be here 2 years ago, I was talking about a couple of these things in my talk there, so I won't dwell on them too much. But I'll give you the link so you can go watch it there. But just in summary, telemetry has to be useful, has to be helpful, has to be actionable, things that you can actually do work with. So just four things that I've been involved in. Observable accumulating hardware timers. That's a very long-winded way of talking about something very simple, which I'll cover in a moment. Low contention heap allocation counters, page tracking segment heap. We'll talk about that just for a very brief moment. And per module thread tracking. What do all these things mean? So imagine you're trying to measure accumulated time doing something in a very efficient way that you can basically stop and start a timer and observe it at very high frequency. Even at the kind of function call level between subsystems. Imagine an atomic integer where, if it's positive, its value means elapsed time, total elapsed time doing some work. But we're not doing that work now. So I can observe that number from any thread, and it tells me this is how much time we've spent doing that kind of work before. The thing that's being measured by that timer. And every time we want to add some more to it, we just add the difference between a start time and an end time into that number, and it just accumulates the amount of time we're doing work. But what happens if I'm another thread trying to observe this system and it's actually doing that work at the time? How can I know both the number, how much elapsed time there is, and whether I'm doing that work in some atomic way that isn't going to involve me having to have a mutex or some other critical section or something around that object to read it? You can do it in a single atomic signed int 64, for example. You can say, when I start timing, what I'm going to do is I'm going to subtract time now from that accumulated time and put that in the number, which now turns it negative, because time now is always going to be greater than total elapsed time so far. It kind of has to be unless we're in a time machine and time goes backwards. So now, if I sample that number from another thread, if it's negative, it means I'm doing that work now. So if I want to know how much work I've done in total, I need to add my current time to that number, and that gives me the total. So it's this really neat little thing. So once we have that, there's more diagrams of how this works in the previous talk, which I won't talk about anymore. Now we have something that's incredibly lightweight for timing things. We can stick it everywhere. So this is actually the kind of block diagram of our main, we have multiple processes, but each of the UI processes in the terminal looks like this. So we have I/O coming into the process, queuing, main thread, event loop, some JavaScript that wakes up, because in order to poke at Chromium, which is our UI rendering layer, this is the web core of the Chrome browser, that doesn't have a C++ SDK. You have to talk through JavaScript to it. So it has a JavaScript engine. We send messages into JavaScript. That then updates the DOM, and we get beautiful displays on the screen that update live most of the time. And we have data processing engines, and we have all these subsystems interacting within the same thread within the process. So I can take these very efficient timers and install them everywhere. And once I do that, I can actually now measure how much time I'm spending doing work in any of these subsystems, and turn that into a real-time display. So I can actually have something like this. So as I'm hovering the mouse over different parts of the system, we can actually see, so the amber here is actually Chromium waking up. The orange is JavaScript running. There's blue, which you occasionally see. It's down here is blue, but it's slight color difference on this screen, is data processing work going on. We have all of this running real time. So I can actually look at an individual system and see, without slowing down that system, really understand how it's behaving. And because these are always on metrics, we can actually sample them in aggregate across all our users. So this is telling me, I think I measured this last month, for 3 months, the responsiveness of the UI thread in the process that is our instant message application called Instant Bloomberg across all users. That instant message process is basically responding to UI input at the I think this is the P90. So for 90% of our users, the response is happening within 34 to 35 milliseconds. And we had a bit of a bad month at the beginning of March where we increased by a couple of milliseconds. But we really care about this stuff. So because this metrics is this set of metrics is so lightweight, we can have it on all the time. We can gather really precise measurements across all our users all the time. So we can very quickly see if there's any kind of performance regression in our system. Instant messaging is really important for our clients. Some of our clients have 1,000 chats open at a time. It is astounding to see. Another thing, again, this is something I talked about in the previous talk, so I'm not going to dwell on it. In order to measure how much memory is being used by each subsystem, the executable DLLs that are loaded into a process, we actually intercept calls to the heap. And in order to measure, we install atomic counters here, so we can actually keep track and say, well, DLL2 is using this much memory, DLL1 is using this much memory, the main executable is using this much. They work really well, apart from if you have multiple threads doing lots of memory allocations, deallocations, where you end up with high contention on these atomic counters. So we have a mechanism we implemented to basically use thread local storage for a linked list of thread local storage across each thread, counters, which we can then accumulate when we need to read them from another thread. Again, I go into detail on this in the previous talk. This just to give you a flavor of the kind of things that can challenge me technically, but don't get in the way of what the team is doing. Another thing is, the actual Chromium layer has its own custom heap engine in there. It doesn't use the system level, and actually grabs pages from the system itself directly. So what we used to do is, in order to keep track of how much memory this was using, we would have this big bit mask covering the whole, at the time, 32-bit address space with 4K pages, where a bit meant that page was either free, we actually use 2 bits, so free or reserved or committed within memory. And that's fine for a 32-bit system. However, if you tried that on a 64-bit system, you'd need a bit mask that's 16 gigabytes big, which is not ideal. So, I basically devised it's a sort of run length encoded version of a map that would store this, and so you could actually have ranges of data to represent, from the outside looks like this big bit mask, and the storage of this thing is like, I think what it came down to 280 bytes or something, for compared to multiple gigabytes. So I still find I can be technically challenged on doing these things. One last thing is we have multiple threads running in different parts of the process in different DLLs. We can enumerate all the threads in the process. Windows allows us to do that. I'm sure any other operating system would as well. But how do you know what all these threads are doing if you haven't got all the symbols? On a client machine, you would not have access to all the symbols. But you can ask the system, where in memory is the code for all the loaded modules? And then you can actually look at, well, actually, using a hidden system call that Windows has, you can find out from each thread where its thread process address is. And then you can match that to where the code is in the DLLs, even without symbols. Now you have a real-time display of all the different threads, which, again, you can have on all the time because it's a very lightweight measurement. So you can understand, am I spending time in the main thread or in this case, Chromium threads, this WTK2 set of threads here, or in some other background threads that are maybe processed at the network layer without actually needing to send symbols or anything like that and really understand what's happening. So just one last thing here, which is that I remember I'd have to do a lot of sort of recruitment interviews and career growth interviews internally at Bloomberg. And one of the things that I ended up often saying was that the org chart does not define your impact. So you don't have to be, head honcho, leader of an empire of 1,000 people in order to have sizable impact within a company. Because impact actually doesn't only come from building product, but actually relationships that you form along the way as you move around a company. My journey itself, I started working directly for the head of engineering. I came as a kind of extra consultant and doing works on feeds, data feeds coming in. When I became a real employee, I got put in a team. And then I kind of moved back. I got an opportunity to basically be a kind of one-person skunk works, modernizing the terminal for a while, which was amazing, but quite high pressure working at that level in the company. Then I kind of moved back and doing some feed stuff, and then I kind of went back to the desktop because I loved that kind of work. Was asked to form a team, working in more of a hierarchy. Actually became a manager of multiple teams. And then as the engineering team overall grew, I effectively was moved down so that we can have another layer in here as well. Although we consider ourselves a flat hierarchy, inevitably you have to have some, when there's 9,000 engineers, you have to have some kind of hierarchy. So right now I'm sat down here, which is actually, if you look at the org chart, is the lowest place I've ever been. And I love it. I'm in a position where I've got 2 teams reporting into me, focused on the things that I really care about, performance and telemetry. Those teams have got amazingly capable people in them, but just being responsible for them means that I can know them all. I can know how they all tick. That none of them are sort of anonymous faces or anonymous names I don't recognize on the PR. I know what motivates each of them, how they tick, how I can best help them succeed in their individual careers. And I think actually working your way down the company is a really great strategy. Certainly, I've found that. Inevitably, AI. I'm sure everybody has to talk about it here, right? But it's important. The world is very much changing. My perspective is this, and I absolutely love what Scott said this morning. I had so many takeaways from his talk about how do we actually process this seismic change so that it can be for the good of all of us. And I took away. I felt good, from what Scott said. These tools are there to help us. I don't believe they're there to replace us. I think they actually empower us when used well. So let's go back to those things that an engineering manager still does on the technical side: breaking down problems, reasoning, system design, balancing trade-offs, and exploring possibilities. Those are the kind of things you can now sort of throw at an LLM, I think. And not only me, but an individual contributor can do these things. So in a way, an individual contributor is taking on some of the role of an engineering leader. in the way they work with LLMs. And of course, they can be really empowered to actually have lots of these things going. Although I found once you have more than 2 or 3, it's a bit exhausting to keep context switching. I do find it quite amusing that for years and years and years, programmers have said, I don't want a context switch, just let me be in flow state doing one thing. And now everybody wants a context switch because you've got all your agents running all the time. But it's, I think we're in a position where what's actually going to happen is individual contributors are going to be developing leadership skills without even realizing it by the way they interact with some of these coding agents. It's going to be interesting to see how this works out. Everyone's at it. So this is the recent GitHub history for somebody not far from here, the guy who runs Shopify. And he's found somebody was commenting on his posts, and they were saying that and he agreed with it. He's taken back the part of the job that he loved but had to abandon when he was running this huge company. The best founders were always builders first, and I think that's quite interesting. So yeah, something to dwell on there. But there is a word of caution, and this goes back to Kelly Vaughan again, actually. She said in one of her blogs, be careful that the gap between productivity and understanding doesn't get too wide. And I think that's really, really key, that you just poke at these LLMs, get them to explain what they're doing, show you're working, as we used to, I remember teachers used to say to us when we were at school. The quality goals for output haven't changed in this new world. Engineers have been, as I say, been fighting context switching for ages. Now we seem to be encouraging it. Beware of burnout. And I think we're in the position where, we might be able to write code or churn code out 10 times faster, but can we actually deploy it at that speed? Probably not. Maybe more like 1.5 times faster. But that's still pretty good. If a year ago somebody had said, I can make you 50% more efficient, we'd have jumped at it, right? So how do I stay sharp? As really in closing here. I've got a bit more spare time now. So in my 20s and 30s, I had kids. Loved that period in my life. In my 40s, now until I guess I'm 60, I got involved in a lot of charity work, endurance challenges, cycling up very steep hills for too many hours. But now, I'm still doing some of that, but I've got a bit more free time. So I'm using these things. I got my Claude subscription, and I've started building stuff. I've taught myself, well, I haven't taught myself. Claude has taught me how to be an iOS programmer, whether it's Back to the Future clocks or audio spectrum analyzers. I love 3D surfaces. Or heart rate monitors shown as 3D, or a simulation of the solar system. Or this was me getting Claude to teach me how to write a particle system simulation that ran on the GPU on my phone. Imagine, can you do that on a phone? It's just amazing, right? But what I've been doing is not just vibing all this stuff, but saying, okay, write the code, now explain it to me. Write me a primer on how to do discrete Fourier transforms, which is what is involved in the DSP processing of audio to do spectrum analysis. And I've been learning so much. I did this, I was inspired by Artemis, the mission around the back of the moon. And I got this thing to build a simulator, running on the phone, running on the web. I had never thought about the fact that when they planned the mission, they didn't fly to where the moon was, they fly to where the moon was going to be. I'd not really thought about that, actually. But the visualization showed me that that's actually how it works. And it taught me Kepler mechanics, which again, I sort of stopped maths at 18. So it's been an amazing journey to learn this stuff and actually get the LLM to effectively write me custom tutorials for how this stuff works. It's really, really powerful, really. And I do feel, I feel the excitement that I felt in my teenage years when I was the one programmer building little arcade games. I really do. So, in closing, this transition from individual contributor to leader can be challenging. But I believe you have it in your power for that change to be good for for you and for the team. Just going back to the bakery thing, they had change. They moved from being a shoe factory, which I'm sure had one kind of smell, to a bakery, which has got a very different kind of smell. But it had become a community hub. It had become somewhere where that elevated people, and it became change for good. I really believe that the change we experience in our careers can be change for good as long as we actually put everything we can into that. Remember that you, the engineering manager, don't need to be the best engineer in the room. However, you have the chance to make it into the best team. I really believe that. So, going back to the topic that we started with, I don't think you lose your technical soul. It just becomes the soul of the team. Thank you very much.